to my YouTube channel. This video, it will be another series of online physics Form 5, SPM Form 5, Chapter 3, Part 5, where we'll talk about transformer. Now, transformer, by definition, in some objective question, what is transformer? It's a device. It's a device used to transfer electrical energy from one circuit to another by electromagnetic induction. Now, previously, I have gone through this already in my previous video. If we want to click back, what does it mean by electromagnetic induction? It's governed by the Lenz's law. Okay, so you may refer to my another video to look at the actual model. How does the transformer look like? You have graphically, you have a block of soft core iron, the one shown in the video. I will put it here. I think here is actual model that I actually open it up using is a power supply for a printer. Okay, all electronics gadgets like your handphone, laptops, printer, they use direct current. Okay, my previous video, I think my previous page, we talk about direct current and alternating current already. So here I want to show you on with that video is actually to show how do you get direct current and step it down to get a stable current. I think you will talk a bit more in the future chapter. So the hardcore, the laminated hardcore iron is actually the essence. Okay, it's actually in layer. And then it's laminated. Okay, it's in layer. It's actually a U shape, but for simplicity, I would just put it as a square. So what we will get is an input. This is my source, one round, and then 2, 3, 4. 4 rounds perhaps. Then this is my input from the 240 in Malaysia or 120 in let's say non-Commonwealth country. They'll be using 120 watt. So sinusoidal, this is alternate current input. Or we don't fix it at 240. It's just an input. We name it as input. There's no value of it yet. I mean, I didn't put any value. Maybe this is a switch. And the output says I want it to be a step-up transformer in the laboratory. Maybe I use a battery sinusoidal. You use not battery, you wouldn't get a direct current. You get a power source and you get alternate current. Then the output I would have says this is 4, perhaps I make more. So I wound around 1, 2, 3, 4, 5, 6, 7, 8, perhaps 8 winding. So 4, 8 is actually double. Okay, so what we're going to do here is I connect it to cathode ray oscilloscope. Cathode ray oscilloscope is a device to look at how the profile. Okay, you have a screen, and then the screen you're able to see a sinusoidal graph out. Okay, and then the amplitude is what you get. From amplitude, you're able to calculate the RMS value. Okay, that's the previous what you have learned here. Previous part, this is what you have learned. You use the maximum voltage, and then you by root 2, then you get RMS value. This is what you have gone through in the past. So here we are going to this part, transformer. How does it work? Transformer mechanism. So the input current, the input alternate current, we name this coil, this side, as primary. Primary coil. And the voltage here is Vp. The one output, what you get is called secondary. Secondary coil, voltage Vs. Okay, subscript S. From an experimentally, what happened if you were to plot a graph normally in a paper 3? They will ask you to plot a graph. If it does comes out, okay, what you need to do is to prove that the primary and secondary coil number and the voltage is actually the same in terms of ratio. So you have primary coil, and the voltage in the primary, and then the secondary, and then the voltage secondary you get, and then you find out the ratio for the secondary voltage over the primary voltage, and then the coil secondary and the coil number in primary. You set up a table maybe just 5 value to set up plot out a graph. First, this is a number of turn. You have unit turn, unit, voltage is V, number is turned, voltage is V, ratio is no unit. So you may fix your primary coil to be, says, maybe 4. Okay, then what you do is you fix the primary voltage to maybe 5 volt. In your experiment, you fix this 2 unit. Then what you change the coil number. So you can't have only one value. I mean 4. You have to be the unit less than what you fix. So maybe you look at says 1, 2, maybe 4, 5, and 8, perhaps 5 value. So you have the number before 4 and the number greater than 4. So the whole range. You cannot have only 5, 6, 7 without any 3, 2, 1. Okay, so maybe the choice of number you need to make it bigger, 10, so that you have more option. But for this case, I use 4. Right? Then you what you measure, the value should be less, and the value here, the ratio, should be the same. If you perform this experiment, the ratio will be the same. The number here will be the same as the number here, the ratio. So then the graph, you plot a graph, secondary coil, secondary winding is direct proportional. And this experiment, I mean, you can conclude that the voltage secondary over the primary is actually the same. This is important. If you want to box it up, it helps you to calculate, to get quite lots of equation out, okay, experimentally. But in terms of theory, how does it work? Now, it works like this. From what you have learned in Lenz's law, the first half cycle, current goes in here, in this direction. What happened? The magnetic field, the north, is downwards. From your right hand grips rule, right? First half cycle. Then this is a soft core ion. So what happened? Magnetic field will be concentrated and then flow through the secondary coil. The first half cycle, yeah, we're talking about. Okay. Then what happened was the electron, valence or electron and copper wire in this coil will flow in a direction against this increasing magnetic field. So what happened? It will flow in the direction opposite. So what happened? It will flow opposite. So therefore, north downwards. Then the current would flow in this direction. Okay. So out from here to oppose it, the Lenz's law. First half cycle. Then you have the first half cycle. Then the next half cycle, this is the first half cycle. The next half cycle, the current flow in opposite direction. Okay, opposite direction. So what happened? Opposite direction. The magnetic field switch. Now magnetic field go up. The other way around. So therefore, you have induction by there's a change in magnetic flux. A change in magnetic flux, and therefore you have an induced EMF at the secondary coil. Okay, and then this cycle repeats, and therefore you will have a sinusoidal voltage. So this is actually very much based on the induction, I mean the Lenz's law. And for ideal, normally in all this SPM question, we talk about ideal transformer, meaning there's no loss of energy. So when there's no loss of energy, therefore the efficiency symbol eta, pronounced ITA eta. Efficiency would therefore be 100%. Ideally, okay? So meaning the input power will be the same as with the output power. Just bear in mind. Okay? Now in reality, it's not the case, because what happened, they will have a loss of energy over the coil. When the magnetic field switch its direction from north to south, south to north, what happened? There's a loss of energy in terms of heat. That's why this coil will be very hot, and you wouldn't want to touch it. You do not touch this coil once after operation, and once after you switch it off, it's still very hot. And the old style, when it's about to fail, what happened? You have the humming sound. So the setup of this soft core, laminated soft core, contribute mostly to the loss of energy. But you need that, otherwise it won't work. You won't be able to step it down. Okay, so efficiency for calculation purpose, it will be the P output over P input times 100%. Okay, this is what you get your efficiency, eta. Alright, so you will want to go through those exercise. For transformer, the calculation should have at least 25 to 30 questions objective for calculation. Or otherwise you have problem going through your exam later. Okay. Normally they will say, oh, what's the efficiency of a transformer? Given, or you should know that by now, power P is equals to IV, where this is current and this is voltage. Normally they will use RMS value for calculation, and whether it's you need to identify whether it's input or output. Okay, maybe we'll go through one example. Okay, to have a block diagram, normally you use a block diagram. You have an input, and then what's the output? Okay, it says well, transformer used to step down certain electrical supply to a light bulb. Okay, says input 240 normally. Maybe here is a light bulb, perhaps output have a light bulb here, doesn't really matter. Rated 12 volt, 2 ampere perhaps. Then if the current in the primary coil, input is where you have your primary and the output is secondary. Always the case, output is secondary. If the current is in the primary coil is 0.15 ampere, then they ask what is the efficiency. Okay, so to calculate this kind of question, efficiency will always be the P output over P input times 100%. So for this case, output, this is where you have your output, IV. So P equals IV, so it's 2 times 12 over your input IV. This is I, this is V, 0.15 I, 240 V times 100%. So you put into a calculator. Therefore, it would be 67%. Okay. So this is how you do it. It's always output over input, which PP is current voltage. Okay. If you're the first time watching my video, kindly subscribe to my channel. It's free, and I really appreciate those thumbs up button. Stay tuned to my next video, and then we'll talk about the factor affecting the efficiency of transformer. Thank you.